All right, we're talking some more about exponential functions. So just a reminder, here is our equation where a is our initial value, b is our rate, and x is a time, okay? If your b value, your base, the one that's raised to exponent, if it is between 0 and 1, then we say it is decreasing, okay? So for example, if I had y equals 5 times 1/3 raised to the power of x, my base, the one that's raised to the power of x, is less than 1. It's between 0 and 1, right? 1/3. So we would say it's decreasing or exponential decay, okay? And our b value would be 1 minus whatever the rate is, the percentage, right? Or percentage changed to decimal. If b is greater than 1, so like my b value that's raised to the power of x, it's greater than 1, so this is an increasing function, and it is exponential growth. It's growing, it's increasing, okay? And to get our b value, it would be 1 plus whatever our percentage is as a decimal. So let's look at some examples down below. Okay, so we're looking at the b value here. What I want us to talk about is whether it's exponential growth, decay, decreasing, increasing, all that. Okay, so since my b value, right, b is the one that's raised to the power of x, so my b value is 0.24. Okay, so this value is in between 0 and 1, which means it is decreasing. Okay, we could say this b value is less than 1. So it's decreasing, and it would be exponential decay. Okay, here my b value is 6. Well, that means my b value is greater than 1. Okay, so this would be increasing. And we would say exponential growth. Right? And this last one, my b value equals 4/3. If you see a fraction, you need to be careful. If the bigger number on top, or if the number on top is bigger than the one on bottom, so your numerator is bigger than the denominator, then this is not less than 1, right? 4/3 is actually 1 and 1/3. It's greater than 1. So our b value is greater than 1. So it is increasing. And this would be exponential growth as well. Okay. All right, so what is the percent of increase or decrease? Okay. So we're looking at our b value to figure that out. All right. So if my b value is 1.38, that is greater than 1, which means we increased, right? We increased from 1 by 38%, right? Because your b value, if it's increasing, is 1 plus whatever your r is. So 1 plus 0.38 is what would give us 1.38. And then 0.38 as a percentage, you're moving the decimal 2 times to get 38%. So let's look here. This is less than 1, right? Which means we are decreasing, okay? So my b would equal 1 minus our r value, okay? So to figure it out, right, if we did, let's work our way backwards. If we did 1 minus 0.45, right, then we get 0.55. So that's what we had to subtract from 1 to get 0.45, okay? Because 1 minus 0.55 would give us 0.45, okay? So we had to do b would be 1 minus 0.55 to give us our 0.45, right? But what we had to subtract our percentage, that we're subtracting is the 0.55. So, 0.55 switched to a percentage would be 55%. Okay. Like here, it's pretty basic. It's what you can see what you added to 1, right? Well, here you can't see what you subtracted by 1 to get to 0.45. So you had to work your way backwards. Well, if we did 1 minus 0.45, then it gives me what I would have subtracted from 1 to get that as my answer, right? So 1 minus 0.55 would give us the 0.45 that we had. But we're decreasing at a 0.55 rate, or a 55% rate. Okay, and then down below, it says graph these functions and tell their characteristics. So let's start with this first example. Y equals 12 times 1/3 raised to the power of x. So we are going to graph that real quick. All right, so based on the equation and on our graph, we can see that it is decreasing. So this is exponential decay, okay? It's decreasing at a rate of 1/3, okay? We know it's decreasing from the equation because our b value is less than 1. We know it from the graph because it's starting up here on the left side and it goes down on the right side. It would have an asymptote at y equals 0, okay, because it's that horizontal line, right? Our asymptote's always y equals something. It's going to be that horizontal line where your function gets close to and never touches. Okay, so it's never actually going to touch 0, but it's going to be really, really close, okay? If you keep zooming in, the more you zoom in, the more you can see it never actually touches that line. It just stays really close to it, right? So our asymptote would be y equals 0. It is your x-axis. Your x-axis is your asymptote. So exponential decay, it's decreasing at a rate of 1/3. Asymptote is y equals 0, which is your x-axis. Okay, if you looked at another example, you can see on this example, based on your b value and on the function, it is increasing, right? We would also see that we would have an asymptote of 2, positive 2, because we have plus 2 over here. And it is increasing at 3 times the rate. All right, write the equation from the table. Okay, so you can see our x values are increasing by 1 each time. So we could look at our rates, right, that we're changing each time. And then since we have the 0 point, we know our starting value, right? So our A is our initial or our starting value. So here my starting value would be 16, okay? It didn't give us a word problem, so we don't know time. We're just figuring out the A and the B right now. So B, it's going from 16 to 4 to 1 to 0.25. So we're decreasing, okay? If you want to know how much you're decreasing by or increasing, either way, you would take the second number and you would divide it by the first one. So 4 divided by 16 would simplify to be 1/4. Or as a decimal, would give you 0.25, okay? So you would do it again. 1 divided by 4 would be 1/4. 0.25 divided by 1 would be 1/4. So that would be our b value. So our equation would be y equals our a times our b raised to the power of x. Right? And let's do it again. So down here you can see we're increasing from 1 to 5 to 25 to 125. And then we know our a value is going to be 1. So our b value, we take the second number and we divide by the first. So 5 divided by 1 is just 5. Okay? So for my equation, I would have y equals, our a value is 1, right? So it'd be 1 times 5 raised to x. What they do when your a value is just 1 is they don't actually write it. We would just have y equals 5 raised to x. All right, and then one last example for you guys. We're gonna write the equation from a word problem, okay? So a vase has a value of $5.20 in 2005. Its value has been decreasing by 2% each year, okay? So our initial value is $5.20, right? That's our starting value, our initial amount, right? B, it's decreasing, so we know we're using 1 minus R, right? And we're given our percent, our R. So it's gonna be 1 minus, what is 2% as a decimal? You've gotta move the decimal 2 times, so it's not 0.2, it's gonna be 0.02, right? Oops, 0.02. 2% is decimal would be 0.02. So 1 minus 0.02, which would give us 0.98. Okay, so this is my B, this is my A, so my equation would be y equals 5.2 times 0.98 raised to x.